Let's get started. Thank you for coming. We're going to talk about automated testing of JavaScript on the client side. So just a quick few words before we get started. Testing, of course, is really what we are after. But to me, testing is an act of gaining insight into applications. What I'm really interested in quite often. So there are two benefits that test-driven development often gives. The first benefit is it gives us a way to do regression. Does the code that worked yesterday continue to work today? And regression is extremely important in software because we want to make sure that as we evolve software, as we incrementally add features, as we fix bugs, as we enhance, we want to make sure that what worked before continues to work now. That becomes extremely critical. But the other benefit that test-driven development can give us is the design benefit. It can help us to improve the design of the code. A lot of times a tactical design where we can iron out the details about the APIs, the functions, what names do we give for these, what parameters to pass in. A lot of these things can help us. My focus here is really not about either one of them for now, but to really illustrate that we actually can develop a fairly good amount of tests. And my focus here is to just focus on the tooling and talk about how we would approach it. The concept of approaching the design itself is pretty big, and I won't even try to get into that. But more so just to focus on, how do we really do it? One of the reasons that I'm really excited about doing this is I worked with clients where I've actually literally walked into organizations where lead developers firmly believe that JavaScript cannot be automated and tested. And then I work with them, and then we figure out ways to do it. And they go from being in a state of denial that this can actually be done to really seeing that this is actually possible. And all I'm trying to do here is to just show you that it actually is possible. What are some of the tools we could use? And it turns out a lot of these are not only fairly fun to use, it can be very effective as well. So let's talk about what it takes to set up a project and start writing some tests on it. My task and test are going to be extremely trivial here. And the reason I want to keep them trivial is I don't want to spend time trying to figure out hard problems. I just want to focus on how do we write tests. Because once you figure out how to write tests, you can figure out the rest of the details. So I want to start by looking at a problem we want to start. So pretty much, I have an empty directory here. I don't have anything at all right now. And I'm going to start with something where we have nothing and see how we can actually set up a project and get that moving. So there are different tools you can use, different things you can use. And all I'm doing is npm init. And in this case, I'm just initializing a project. So I just pretty much took all the defaults you can. So the only command I ran so far is npm init. And all this did for us was it created this package.json file. So let's go ahead and take a look at the package.json file. It doesn't have a whole lot right now in it. It's got a few mundane things about the project and not a whole lot. But this is where I want to start my work with. This is a project I've just created. You could use different tools to do this as well, but I'm just using npm init to create this project. Now that I've created this project, why do I care about the package.json file? Well, one of the reasons is when you work in a team environment, one of the things we have to be very sensitive about is there is nothing more valuable than time. It's kind of weird, right? Time is infinite, but each one of us is given a very finite amount of it. How cruel that is, right? And once the time is gone, we can't get it back. So when we work with teams, imagine you decide to use 3 or 4 different tools, and then you start using them on your project. And then you check your code in. And then you walk away. Your colleague comes in the afternoon, checks out the code, and then sees that the code doesn't work anymore. And then they spend the next 20 minutes, 30 minutes trying to figure out what tools you are using, and more important, what versions of tools you are using. They figure out what tool you're using, they install it, it doesn't work because you're using one version, they install another version. That's a lot of time wasted. One of the things we need to be very sensitive to when we work in an organization is how much time we actually waste. I get really angry when I see this. I'm a consultant, and I get paid for being a consultant. And when I walk in, I would ask somebody to do something, and I would watch them spend sometimes 30 minutes, sometimes 2 hours, just to get a few things installed on their machine. And that's a waste of everyone's time on the team. Well, what you do is when you install stuff, the package JSON can make note of it. So I'm going to do npm install, and I want to install locally. If I install globally, I can affect other projects, which again turns into waste of time. So installing locally is a good thing. So npm install, I'm going to install Mocha and Chai, but I'm going to say save dev. Now again, there are several tools you can use. A lot of people in this industry use Jasmine, and Jasmine is a really good tool. There's nothing wrong with it. I just prefer Mocha and Chai for most of the work I do. But if you want to use Jasmine, just replace the word Mocha Chai with Jasmine, and you can install Jasmine. Mocha is a testing tool, just like your JUnit is if you're using Java, or NUnit and things like that. But Mocha itself is pretty smart. It lets other tools do the work of assertions. Chai provides the assertion. So Chai says you can use an assert like you do in JUnit, or you can use should if you want to use should, or you can use expect if you like to use expect. So Chai actually gives you 3 different assertion libraries. I'll use expect here because I just like using expect. I've used assert for a long time. Kind of tired, so I said I'll use expert. But the most important thing I want to point out here is the save dev. So before I run it, if you notice, there's nothing about Mocha and Chai in the package.json file. But if I go and run this now, it's installing Mocha and Chai and getting it downloaded and installed. But once it does that, what's going to happen here is it's going to update the package.json file to say that I need to have these two to run this project. But the benefit that this gives you is once you go ahead and install it, and then of course I'm going to make sure that this connection is working here. So once you install it, looks like it's pretty slow. So once you install it, you're going to have those updated on your package.json file. Then the benefit is when you check in your package.json file, your colleagues, all they have to do is just do npm install, and then they have those tools installed on their machine automatically. Well, one of the things I also like to do is to do continuous integration. I don't want to just assume that tests work. I want to constantly run. So I have a continuous integration server running for my own project. And in fact, anytime I check in code, or even otherwise, every 15 minutes, it pulls the code and executes it. Well, what if I decide to use a new tool? I'm going to install that on my machine, check in the package.json, but I don't want to manually log on to the continuous integration machine and make any changes. So what my CI does every time is, it wakes up, pulls the code, and the very first thing it does is just npm install. And that way, if I installed any tools, or if I made any changes to versions, it gets reinstalled automatically, so I never have to log on and babysit my machine. It is truly a continuous integration, which is automated. I don't have to mess with it. So that is one of the biggest benefits you get out of doing this. And as you can see, this is actually extremely slow. But that's what we're going to do is install these tools as we go through. One of the other things I would not normally like to do is to start with a canary test. What is a canary test? A canary test is the stupidest test you could probably write. A canary test is simply useful to make sure that the necessary tools are installed properly on your project. Now suppose you write about 20 or 30 lines of code or test, and then things don't work and you call for help. What do your colleagues normally do? They come in and ask you, what are you doing? And you say, I'm trying to run this test. And they're going to have all kinds of opinion about your code. Oh, I don't think you can make that call over there. I don't think you can talk to this server. And you're trying to tell them, you know what? I don't think any of that is a problem. I think I've not set up the tool properly. Can you help me with that? But that's really hard to get past that because you don't have something really simple with you. On the other hand, a canary test is the stupidest test you could write. It says assert true is true. I mean, what could be anything less than that, right? And that's the stupidest test you could write, but you're trying to make that test work, and if it doesn't, you call your colleague and say, hey, can you help me fix this problem? Your colleague says, what are you trying to do? I'm trying to do assert true is true. Your colleague says, well, that's stupid. Yeah, it shouldn't take much time to do stupid things, right? So why don't we make that work? So it gives you the focus on that. That's one of the reasons to start with something like a canary test. And this also helps you to know when you change environments or go onto a new machine, You can know that things are actually still working or not by just focusing on the canary test. So to run the canary test, what I'm going to do, boy, this is still running. It's going to be disappointing, I think, because it's still installing here, even though I have the connection to the internet. So what I'm going to do here is, to be able to run this, I need a directory where I can put this. So let me see if I can make a little bit more progress while that's still running. So what I'm going to do here is I need a bunch of files to work with to begin with, obviously. So I'm going to start with a directory source and a directory test. And obviously, I'm going to put my test in the test directory and code in the source directory. Well, typically, when you're writing a front end, you most likely have a back end as well. So what you would typically then do is you could write a test directory, but within the test directory, you could create a server directory where you can put server-side related tests. You could put a client where you would put the client-related tests. That way, when you run the test, you can say only run the client test on the client side and run the server test on the server side. In the same node, you would also have integration where you would put integration tests. So you can start creating these subdirectories. Since we are only focusing on client side, I'll save my trouble for myself, but that's what you would do. You would create these subdirectories for you to do stuff in here. But I want to start with a little test here. So in the test directory, I'll create a sample test.js, and this is simply going to be a very simple test. So I'm going to start with a describe, and I'll call this as a sample test, for lack of better words. So describe is what you're going to see mostly in Mocha and also in Jasmine. This is a definition of a test suite. So you're going to put all your tests within describe. Well, the beautiful thing about this is every file can have a describe, but you can also nest the describes as well. So every describe becomes a suite of tests. So if you want to focus on 3 or 4 different things, within a test file, you can define them as separate describes. Then when you look at your test output, you're going to see those divisions in there. So that becomes a really nice way to keep track of the group of tests that you're running. So in this case, I want to start with a little test. And the first test I want to write here, I'm going to call this as should pass this canary test. So what in the world is a canary test? Well, the word canary test really alludes to the phrase called the canary in a coal mine. Well, the miners were known to take a little bird, canary, in a cage, and canaries were very sensitive to the fumes that humans are sensitive to. Except being very small, they are super sensitive than we are. So if something is going to hurt us and kill us, it would hurt and kill the canary really early. So this was a sacrificial test. This was really good for the miners, not so much for the canary, unfortunately. So when the canary smells these fumes, the canary would die, and when the miners take note of it, gives them an early sign of trouble, and they can exit very quickly. Well, it's the same idea. We're writing a sacrificial test just to see if it's totally going to blow up and nothing is going to work. So in this case, I'm going to say expect a true, and then of course to be true. So this is the stupidest test I was talking about, right? You're saying expect true to be true. There's not a whole lot going on here, except to verify that you're able to verify that true is true. Now this is going to only work if you're able to run the test, if the testing tool comes together, if assertion library works together. So all that has to be. And the beauty of this is you are doing all this just to verify your environment without really tying yourselves to the particular application you're working with. Remember a day when I was working with a client, they wanted to do TDD, so I was coaching them. So I walked in the morning and they said, we got this very complex refinery we're going to test. And it's like, wow, there's a lot of complex things we're going to work on. And they said, where do you want to start? I said, let's write a canary test. Like, what is that? Well, assert true is true. He said, that's stupid. Like, yeah, so that shouldn't take a whole lot to run, isn't it? It took us 40 minutes to get the canary test to pass because we had so many configuration issues on their machine and platform. And if we had written real code, and everybody would have had their own opinions about why that wouldn't work, whereas this is extremely, to the very simple form, just make this one thing work, that becomes a lot easier. But unfortunately, though, to run this, I need a few things. If this was a server-side code, boy, this is really hopeless, isn't it? I'm going to kill this and try this again, see if that's going to come through. So let me see if the internet connection is even working. So that might be a showstopper actually, because I'm relying on that for what we're going to do here. Well, we'll see how much we can go. So unless we have a better connection. Simran, do you think we have a better connection here by any chance? So, so what are we going to do here? Well, in this case, of course, I'm going to need to run this. So what am I going to do to run this? Well, if this was a server-side code, clearly what I would have done here is I would have just run this in Node. And once I run it in Node, I can get the feedback right away. But this is a client-side code. Well, you know, what if I can take this JavaScript and run it in Node still? Well, sure, that's one approach, but I would strongly discourage doing that. The reason is, part of the problem with JavaScript is the code is not right. But the other part is, the code is right, it just doesn't work in this browser. So you want to catch those browser problems pretty quickly as well, otherwise it's not going to be much fun at all. So what you want to do is not only know that the code is actually working, but it also works on this particular browser. If your product is supposed to run on 3 different browsers, you definitely want to make sure it actually works on those 3 different browsers. That's where Karma comes in. So Karma is, well, to run code on the client side, you need to have a web server. And then the web server is going to host your code. Your browser is going to, of course, bring the code over and run it. But you don't want to run this on your real server, at least not in this case of unit tests. So what you can do in this case is, you could pretty much say, well, I am going to go ahead and set up this Karma. Karma is a web server. Think about it this way for a minute, where the Karma web server says, I'm going to host this code, and when you run the test, I'm going to dispense this test to the browser, run the test in the browser, collect the response of the test, and then, of course, display the result for you. Now, it can display this result on the console. Why is it so important that we can get this on the console? Well, if you cannot run the test on the and get the result on the console, your test is as good as being dead to me. And the reason I say that is, if you can automate this without an IDE, without an editor, then you can automate that in a continuous integration server. And the goal should be to really go to continuous integration. Because if you're running your test manually on your machines, there are going to be times when you won't be able to run it. You may be on a vacation for a week, and you come back and you notice the team has gone on written other code, and the code has not been integrated into these tests, and that's going to be a very late warning sign. But putting in the CI is extremely important. So normally what I say is, the minute a test passes, don't go to write the second test. Put that one test in CI, and make sure it runs in the continuous integration environment, and then come back and write the second test. And that way, every investment you make in writing the test is continued to be evaluated along the side. That becomes extremely critical. So in this case, of course, we need Karma, and I don't think I can do anything more without the internet connection here. So I really apologize for that. So in this case, of course, I need to install more tools, and without the connection, that's not going to be possible at all. So what can we do? Okay, this seems to be responsive a little bit here, but not enough to get me the response I need. So anybody? Done it on what? It doesn't matter. I got to install stuff on my machine, and it's got to come from NPM. Oh, that'd be great if you can help me. Awesome. Why don't you take over and do what you have to do? Thank you. Appreciate the help. Awesome. What's your name?
My name is Shobit.
Shobit, thank you very much. You are our hero today.
Let's see. I hope I will.
It's connecting. Password.
Just give me 1 moment.
Sure, take your time. No pressure. So what's Karma going to do? Karma says, I'm going to host this code, dispense it to the browser, and get it executed in the browser and bring it back. We need to set up Karma. Well, Karma requires a few things. Karma needs to know testing tool you're going to use. Karma needs to know where your test is going to be. Karma needs to know where your source code is going to be. Karma needs to know what browsers you want to use. So there's a whole bunch of things Karma wants to know, right? Well, how do you provide all this to Karma? Well, you can do that by using a karma.conf.js. And when you provide this in karma.conf.js, when you start Karma, Karma will look at karma.conf.js, figure out all these details, the browser you want to use, where the location of the files are, and such. And then once it does that, it's going to be able to pull that and run the test. So we got more people trying to help. That's awesome. Thank you. So that's basically the idea, is that you're going to bring together these tools to work. So we're going to use Mocha, we're going to use Chai, we're going to use Karma. But Karma also needs a few more plugins. We got a Mocha plugin, we got a Chai plugin we got to use. So once we bring those together, it's going to be able to use that. Let's see if we're making progress on this. All right, awesome. Thank you very much. How about a show of hands for them for such a wonderful help? Thank you. That is progress right there. We are making progress. Awesome. You made my day. Thank you. Awesome. Okay. Now can you come and write the test also for me? Okay, thank you. So we installed those tools. What I wanted to show you earlier was this part, where it has the Chai and Mocha installed right here, and you can see that, well, what's the purpose of this? Now, of course, I can blow away my node module directory. I can run npm install again, and it's going to just install those back for you without having to manually do this. Well, what I'm going to do is I'm going to do npm install Karma. But like I said, Karma needs a lot of other things as well. So rather than doing it this way, I'll just have a little note here. So I'm going to install Mocha Chai, and we'll come back to this in a few minutes. So we'll just ignore that, pretend it's not there. So we want Karma CLI, command line interface. We also want the Karma Mocha and Karma Chai, and we're going to bring those things also. And then, of course, you need the Karma Chrome launcher. If you want to run this in Chrome, if you want to run this in Safari, Karma Safari launcher, Karma Firefox launcher, stuff like that. You can, sorry, what did I hear? Sorry, I didn't hear you. Okay, so, and then you can run all of those. And then, of course, I'm going to use a save dev, as you can see, right? So save dev is going to just make it available for us so we can use that all on this. So I'm going to install all of that. And what happens when you finish installing it? He gets a very big bill for the internet connection. I apologize. So that's basically what we're doing. We're just installing all those stuff. So great. Now, one of the things is when I started playing with Karma, the very first day when I ran it, I got really angry because Karma displayed stuff on the screen. And then when I save my file, it has an auto mode, which is nice. It immediately displays the output next to it. And I'm like, wait, is this a previous test or current test? And if you notice, honestly, different people work differently. So it's nothing, about one versus the other. But the point is, in all honesty, this is my desktop. And my desktop has absolutely nothing. And the reason is, I don't want to be ever distracted. I want to only be unifocused. I want to see what I see. I don't want to ever be disturbed by what I don't want to see. When I go to somebody's machine, when they have 1,000 icons on the machine, I really bow to them. You're awesome. Because somehow you know which icon to click on, right? I can never figure this out. So on the other hand, we know that searching is much better than going through a menu. So you want to launch things based on just typing and searching things or other mechanisms. In the same way, when Karma displayed the whole thing on the screen and then displayed more, I got really angry and I quit immediately and I started searching. This was one that I found made me really happy. This is called the Karma Clean Screen Reporter. Install this plugin and beautifully it clears your screen before running the test again. That made me so happy because then I'm looking at the screen, only things I want to see right now. If I really want to see the previous test, I can always scroll back, but I rarely do. I want to see what's happening right now, not what happened a little bit earlier. So we're going to install those, and we did, and you got all those bunch of stuff that just got added, as you can see. Time for us to play with this. So what's the next thing I'm going to do in here? I'm going to go back here now after having installed all of that. And in this case, I'm going to say node modules, karma, and then bin karma init. So we're going to initialize karma. And what does karma say? Do you want to use Jasmine? If you want to use Jasmine, say yes. Well, I want to use Mocha, so I'm taking that. Do you want to use require? Not really. Would you like to use Chrome? Yes. But you can tab through it. Would you like to use Chrome Canary, which is another version of the browser with some really new features? No, not really. Would you like to use Firefox? If you want to test your code in multiple browsers, all you have to do is just install the multiple things. Either now or later, doesn't matter. And once you do this, it's going to go ahead and install that for you. Would you like to run this in Safari? Would you like to run this in Phantom.js? Phantom.js and I were good friends. We used to go out together all the time. But one day I found out she doesn't support bind function. My heart was broken. Then I said, it's okay, we can get along still. Then I found she doesn't support geolocation. We broke up that day. And we said, no, we're not going to deal with this anymore. But Phantom.js is a nice headless browser. So if you want to run it on a CI machine, you could use Phantom. But it turned out that once I kind of broke up with Phantom, I realized Chrome was not that bad. It just launches a window. You can ignore it. You can minimize it. If you have multiple windows already running, this window comes up, but when you kill Karma, it only kills that one window. So it only is mildly annoying for the features it provides. But of course, if you want to use Phantom.js, say yes. Would you like to use Opera? Raise your hand if you use Opera. That is the one user in the world, right? And there's one more. This is amazing. I've seen 3 people in the world so far. Opera is one beautiful browser. It is always current with the latest feature. You know why? Because nobody complains if it changes, except for these 2 people, right? And so if you're using Opera, sure, invite it. So you can choose these versions if you want to. And then, of course, take the defaults for the rest of the things. Let's take a look at the karma.conf.js. So what are we going to do here? I want to use Mocha, but I also want to use Chai, bring those plugins. And what are the files you're going to use? The files I'm going to use here are, first of all, test, all the subdirectories star.js. And I also want to use, from the current directory, source, all the subdirectory star.js. So you're simply telling Karma what files you want to use. And then once you do, the next step here is, if you want to exclude something, you can say that. And then, of course, when you come down here, there is a section called Auto Watch. This says, do you want to keep running Karma? And when you click on the save or save your files, do you want to rerun it? This is where you would add new browsers if you want to add them afterwards. So if you want to add Firefox and Safari, throw them in here, install the proper launchers. When you run a test, it'll run on all those browsers. So that way you can get a feedback on different browsers at the same time. So that's pretty much for now. We'll just keep that for now. I'll come back and change a few things a little later. So it's time to let our Canary test run and see what happens. So, but I have to start the test. For this, I go back to package.json. And in the package.json, there's this beautiful thing called test. Again, if I'm running server and client test, I would normally call this as server test and client test, so I can run them separately. So what am I going to do for this test? For this test, I'm going to say karma start. And what does karma start do? Let me try this. So karma start is going to run some reporters. I'm running the clean screen reporter and the dots reporter. The dots reporter is for people like me who are very impatient. If you're running a test, if it's taking a little longer, I'm like, is it stuck? Well, the dot is very soothing. It puts one dot at a time so you can kind of watch it. So that's the dot reporter. And then, of course, you know what clean screen is. I talked about it a minute ago. Let's go back to what this is going to do. Now that we have set this all, npm test to run the test. So this starts up Karma. And notice a Chrome ran in the background. And you can see that it says success right there. That says that one little test we wrote actually works. Thanks to you, we were able to install these and run it, so our Canary test is passing, right? Had I written 30 lines of code, he would have said, internet is not your problem. Your code sucks. Well, at least now you know that it was really the tool that we needed, and we were able to make it work. Awesome. Now what are we going to do? The next step, of course, is we wrote this little test, but let's break it. So let's change it to false right here. All I did was change it to false, and I saved it. That's all I did. If you quickly glance at it, it's all in red, as you can see. The test actually failed. That was an instant replay, instant feedback that the test is not passing. Go back and change it to true, of course, and you can see the test is passing. So it's watching over what I'm doing. The minute I hit the save, it's rerunning the test. So we have our Canary test passing. That's our very first step. So what did we do? We got a few tools installed. We installed Mocha, Chai, Karma, all the plugins needed for it, the browser launcher, and then the clear screen plugin. That's pretty much right. And then we initialized Karma using init, and off we go. Great. Let's write a silly test here, just for our purpose. So I'm going to go here, and I'm going to say, let's say, divide. So divide, let's say, should return 4 when 8 is divided by 2. So again, a very silly example I'm creating here to illustrate the point. So this is going to be divide 8 comma 2 to be equal to 4. So this is going to obviously fail. And the reason it's going to fail is divide doesn't even exist right now. So that's why it says I'm failing right now. So we got to write the divide function. So what am I going to do to write the divide function? So I go to, well, I don't have the file. So let's go create the file. So edit source sample.js. And of course, I'll restart the test, let it fail, and then we'll come back and edit this. So what am I going to do in this file? I got to create a divide method function. So we'll go ahead and say in here, divide. So we'll say function divide is going to take a number, and it takes another number. But this is beauty of JavaScript, right? JavaScript is the most flexible language you could get. What does this function want? It wants to return a 4. So simply return a 4 right now. That's enough. You don't have to do anything more. So one rule of TDD, you don't do any work until the test demands it. And then when the test demands it, you do minimum work to get away. So you say, well, that code is not enough. Well, then write more tests for it. Don't write more code without the test failing. In this case, of course, JavaScript says, I'll just call it. You say, wait a minute, you passed 2 arguments, but how come JavaScript didn't complain? That's because JavaScript is so happy you're using it. It's not going to complain to you, right? So it's like, whatever, just call me, I'm so happy. So in this case, you call divide, you didn't pass anything, it says you're not using it, I don't have a problem with it. This is awesome, right? So now what do? I'm going to do one more thing. I'm going to say divide should return a -4 when 8 is divided by -2. So I'm going to divide 8 by -2, and it better return a -4. Now what happens in this case? The test is failing, of course. Why is it failing? Because it says, gosh, you gave me a 4, but I'm expecting a -4. Now we got to do some real work. So I'm going to go back here to the code and say op1 and op2, and all I'm going to do is return op1 over op2, and of course, go back, the test is passing, so we wrote it. So when you're writing tests, there are 3 kinds of tests you're going to write. The first kind of test you're going to write is called a positive test. A positive test is simply saying, I'm going to do this action, did it actually work? That's all a positive test is. So a positive test is useful to just make sure that your code is doing stuff in a happy path. I'm depositing $100, did my balance go up by $100? The second type of test you're going to write once you get through positive tests. So when you're thinking of tests to write, you want to think about these 3 types. The second is going to be called negative test. A negative test is where you're going to ask your code to violate the invariant. Invariants are extremely important, right? Invariant says, this shouldn't happen. This should never be violated. And you want to make sure your code does not violate invariants. You don't assume your code does things. You want to verify that your code does things. So you write a negative test. For example, I'll give you an example of this. I once had a mortgage with a bank, and I decided to refinance it. And when I refinanced it, the new mortgage company took over the mortgage. The old mortgage company got the money, and I got a better interest rate. Everything is good, right? So this was the days before the internet as we know it today. And I get an email from my wife. I was on a trip, and she said, I don't mind you taking money from the bank, but if you do, I would really appreciate if you let me know. So really angry email, right? I said, I'm sorry, I don't even know the account number. You do everything for me. So if the money is gone, we're in trouble. I didn't take it. She replied back saying, we're in trouble. So apparently we were losing some money. And she's really good at patterns. Then she came back and said, oh, I know what's going on. The money is twice the mortgage amount we used to pay. We tracked it down eventually. And what we found out was we had an automated payment to the bank. Well, it turns out when they closed the account and moved the mortgage to another company, they forgot to take away the automated payment. And then when we tracked it down, they said, oh gosh, this is funny. That's what they said. It's taking money into and putting in the closed account. I said, that's not funny actually, because it's my money. So now that you figured it out, could you please return the money to me? And the person said, there's a problem. The system doesn't allow me to take money out of a closed account, rascals. Banks do this all the time. So obviously somebody didn't write a negative test. Like, hey, you can't put money into a closed account. What a great idea, right? So that's an example of a negative test. You want to know you shouldn't be doing this because the state is not valid. A third type of test you want to write is called an exception test. So what is an exception test? If your code is supposed to throw exceptions, you want to make sure it actually throws exception. Now, a lot of times people will say, well, it's an exception. They should have called it normal, right? It just happens. And if you cannot simulate an exception, then how do you know what your code is going to do when the fateful moment happens? Well, you can't wait until production and find out, right? And that is what is, if you wait till production for things to fail, what is that called? Bad karma, right? And there's a reason why we're using tools like karma here. So let's favor good karma. So what are we going to do? We're going to write an exception test and test for it. So to do that, let's write an exception test. So what am I going to do? I'm going to go here and say, well, I'm going to write this test should throw an exception for divide by 0. Well, fair enough. So expect, oh, wait a minute, it's a blow up. How do I write a test for it? If you're using tools like JUnit or NUnit, you might have written a try and a catch, and then you would have said a fail, or you have used annotations for it. Neither of those approaches are really good. And in fact, NUnit, the C# testing tool, has moved away from using annotations or attributes. JUnit is moving away from that also in JUnit 5 because that's a terrible idea. And all those tools are moving towards what I'm going to show you here, which is to really write a way to assert exceptions. So you say expect, and what do I want to expect? Well, what am I going to put here? Dot to throw, and I'm going to say divide by 0. So I'm expecting the code I'm going to call there to throw divide by 0. But there's one problem though. If I come in here and say divide and send, let's say, 4 and 0, guess what's going to happen? We know that in languages like Java and JavaScript, when you pass the argument to a function, the argument is evaluated first, and then it's passed to the function, which means the highlighted code is going to blow up right now. And when it blows up, it's going to kill the test. And you never gave a chance for expect to even come close to it. What you really want to do is you want to take this little code and you want to put it in a box and you want to blow it up and then see if it contained within that box. So how do you do this? Well, in software, we have this beautiful, beautiful idea. I can tell you that I'm not excited about anything more than this. This is the words of a guy named David Wheeler. He said something phenomenal. He said in computer science, we can solve almost any problem by using one more level of indirection. This is phenomenal. By using one more level of indirection, you can solve almost any problem. Honestly, I can't tell you, there is not a single day I don't pause and admire at this. Because I mean, if we were to give a Nobel Prize for software, I would give it to him. Because this is very profound in my opinion. Because you can solve almost any problem by using one more level of indirection. Well, what is the level of indirection here? Well, rather than calling this function, send a function that in turn will call that function. So in other words, you can get lazy evaluation using lambda expressions very nicely. And that's exactly what Mocha does and other tools do. So you say expect that lambda to blow up. And you're waiting until expect will come and call that lambda. So that's pretty nice because expect says, oh, when I called that lambda, it blew up, so you're okay. But if the lambda did not blow up, then you're not okay because it's an exception test. So it turns out in this case, when I save it, and I come back and take a look at it, look at that, it did not blow up. Well, that's because it turns out JavaScript did not do what we expected. But when was the last time JavaScript ever did what you expected? So that's the whole point of writing tests, isn't it? So scratch that, let's go to node. Let's do 4 divided by 2. Hey, that was a 2. 4 divided by 0. What would that be? Of course, it says infinity, because that's much more wonderful. So in this case, it gives you infinity. If that's not what you wanted, you got to do something different. So what am I going to do? Well, the test is failing, but I'm going to go to the code and I'm going to say, all right, you can do this in several different ways, but here I'm going to say if op2 is equal to 0, then throw, well, what am I going to throw? I'm going to throw divide by 0 error, right? So that's what I'm going to throw here, divide by 0. I mean, you may wonder, are you serious? Can you just throw a string? I mean, that's the beauty of JavaScript. In Java and C#, you can only throw exception. In JavaScript, you can throw anything you want. It's like being in a bad marriage, right? Anything flies across the room. It doesn't matter. Just throw whatever you want to throw. So in this case, I'm just going to throw that particular divide by 0. So let's save that and see what happens. You can see the test is passing. So all we did so far is write these tests. You know, the code you're writing, you're going to do something very similar. You're going to be sitting there and writing more code to do this. So I won't go into more details. But at this point, it's probably a good idea to see how we could, let's say, go back and do some more little work here. Now, one of the things I'm a huge fan of is code coverage. People get angry when I talk about code coverage oftentimes. They say, oh, code coverage is awful, we should never look at it. I'm actually a huge fan of code coverage. Let me ask you one silly question. If you always write code, if you always write test before you write code, and you write minimum code to make the test to pass, what do you think your code coverage is going to be? 100%, right? So, but a lot of times, we don't want to do that. We want to just kind of sneak in code. But I'll tell you one thing though. Code coverage is like cholesterol number. If I go to the doctor and say, Doc, how am I doing? Doc takes blood test and says, you got high cholesterol, Venkat. You got to fix things. You got to exercise. You got to eat healthy. You got to take some rest. Here are things you need to do. Otherwise, it's going to be really bad. So for 6 months, I do everything the doc says. Take medicines, work out, take good food. And then what happens? I go to the doctor looks at my cholesterol and says, I don't know what you did, but you did really good. Good job. Continue doing it. Immediately I give a paper and say, here, sign here. They're like, well, what? Tell me I'm in good health. What do you think the doctor is going to say? Will the doctor sign it? No. Why? Because the doctor says, your cholesterol is okay, but doesn't mean you don't have any problem. You don't have that problem, right? So the point really is, code coverage is like cholesterol numbers. If you have really bad coverage, you have that problem. If you have a good coverage, there's nothing to celebrate. You just don't have that problem. But invariably, I do a lot of code reviews. And when I do code reviews, often people will come to me and I would say, oh, this coverage is really bad, you got to fix it. So this happens almost all the time. And I'm waiting for the day when I'm wrong. I'm serious about it. I'm really waiting for the day when I'm wrong. But developers will email me and say, I know, you're going to look at this code in the next few hours, and you're going to see the coverage is poor, and you're going to kick and scream. So I will tell you right away the coverage is bad on this code. And then they would add to that note, I read somewhere that coverage is not the most important thing. They never tell me where that somewhere is. But I read somewhere that we should not focus so much on coverage. I almost always ignore these comments. When they tell me there's a poor coverage, I just go into the code. And the minute I go into the code, I'm not even thinking of coverage anymore. I see a code smell or a design smell. I refactor the code. I suggest them to make a few changes. They make the change, and the coverage is back to normal. And we never seem to talk about the coverage after that. So what I've seen in my personal experience is, every time I see a low coverage, I see a problematic code, and never an issue with coverage after that. Because it's usually kind of infested with problems, and it kind of attracts you towards it. And then we fix it, and the problem is gone, and the coverage is good. So usually, I look at coverage very seriously for that. But how in the world can we look at coverage? That's the beauty. You don't have to do much at all. npm install, and there's this beautiful tool called Istanbul. And Istanbul, save dev again, and Istanbul is a really fantastic code coverage tool. You don't have to do a whole lot at all. Istanbul will, instrument your code, and it will measure the coverage for you without almost any effort, so that becomes really easy. If you're doing this on the server side, you're done after installing Istanbul. But we're not on the server side. We're on the client side. Something has to run, Istanbul. But who is running the test? It's Karma that's running the test. So as a result, we have to do one more thing. We have to come in here and add the Karma plugin for this also. And I have kind of, it's sitting here, which is the Istanbul plugin. And then you can just say Karma Istanbul, and then you can bring that in. Actually, it doesn't seem to exist here. We'll see what happens. Okay, so you're going to install that. Let's try that. There's one more thing you have to do. We'll come back to that. So I've installed Istanbul, and I've again did a save dev. Save dev because we only need it for development purposes. So once I install this, what's the next step? We got to tell Karma to run the coverage. Well, to do this, I'm going to go back to the karma.config file. So it looks like this is taking a little longer. Maybe the connection has gone to sleep. We'll see. So what I want to do here is I want to edit the karmaconf.js. I'm going to go here to the processor section. And in the processor section, I'm going to say, under the source, go ahead and instrument all the files under the source and use the coverage for that. And once you say this, then you go to the npm test, and you're going to add the coverage right here for it to be bringing it in. So in this case, of course, it's got Istanbul, as you can see right here, but I'm going to just add coverage to that. Now, once I do this, but before I run this, let's sneak into the code and do something absolutely stupid. I'm going to say if op1 is equal to 1000, I'm going to say op1 is equal to op1 times 1. Just a silly code just to illustrate the point. Now I'm going to go back here and do npm test. Well, if you don't want to run the coverage, what you could do then is you could run this separately in your test. So rather than running it in the automated mode, you can ask it to run in a single run. So you can simply say -- single run, and then you can include the coverage. So what I would typically do for that is I would keep the test separate like this, and then I would do cover, or you can say client cover, that we can have server-side coverage and client-side coverage. In this case, of course, I start this, I'll say single run, and then I will bring in the coverage into this. So now that I've added a new thing called cover, I'm going to say run cover. I usually make fun. If you do automated testing, you do run cover. If you don't do automated testing, you run for cover. So it's up to you. So the point really is you can just run the cover, and this is going to run the coverage and bring this in. Let's see what error it's giving us. It's complaining that error Karma found two load errors, and it's having a trouble with, let's see what the error actually says. Run cover, and then its case Karma start, blah, blah, blah. Failed to be automated, single run. And what's the problem? Make sure you have the latest version of Node. Tell me what really is going on. So it doesn't really tell us what's going on here, but more than likely I need the plugin. So let's try this. npm install Karma Istanbul, and let's say save dev. So let's go ahead and install that. And then once we do this, let's go ahead and run the cover again. So run cover and see what it does. Oh, still has an issue. Let's see where it's giving us the error. So tell the author that this failed. Yeah, thank you. So what does this do really? So please include the following. So it doesn't really tell us what happened, isn't it? Yeah, there's likely additional blah, blah, blah. So it's not happy with some configuration I probably made over there to tell me what the configuration file is. Let's see. All right, I'm going to look up a file here to see if I can bring in maybe a little syntax. Maybe I'm messing with it. We'll find out. So let's go ahead and try to bring one example of a Karma file here. So in here, I'm going to go to cover. So let's bring this one into preprocessor. I put it in the wrong place. That's why. So let's go to coverage, which is sitting, more than one error then. Okay. So let's go to processor. Sorry, wrong file. So let's go to the processor. I was in the right place. And what did I do wrong here? So under the source, I did bring in star.js. So it looks like my syntax was actually correct. So that's not the issue. Let's see if I have, in this case, Istanbul. I don't think I need that, but let's see. We'll try one more time, otherwise I'll try to see if there's any other configuration that's missing in our case. So let's run this. Still, okay, one more try. Let me see what else I have included here. So I have the coverage. I have nothing else installed. Let's quickly take a look at the package.json. Maybe I have something I don't see here. So in the package.json, I'll look for Istanbul. And that's a client side. And then I said coverage. Nope, I can't, and it's a single run. So I don't have a clue what's failing it. So let me try this one more time. So Karma, and then coverage. And maybe the option is not in the right place. We'll try this one more time, otherwise we'll move on. So let me try this again, but putting the single run in the end. Let's try this again. Okay, all right, let's move on. So what it should have done is, it would give us a coverage, and we should be able to see the line numbers where the coverage is happening, and we can figure out some kind of configuration error that I'm facing here that it's not too happy with. All right, so you can look at the coverage, but there's one other concern though. Writing test is very easy when your test has no dependency. But real life, you have dependencies every corner you turn. So what do you do with dependencies? How do you tackle that? Well, when you have dependencies can really make it hard to write test. Dependencies can slow us down. Dependencies can be unpredictable. Dependencies could be really non-deterministic. So what do you do in these cases? It's easy to fall back and give up. But thankfully, we don't have to do that. We can do quite a few things that we can do effectively. So this is where we want to use so-called test doubles. So what is a test double? Well, first of all, don't just get dragged into test doubles. See if you can actually move the dependency around so a particular code may not have to have dependency. That's a technique we have to use before we consider using test doubles and testing with dependency. But try to move things around. And if you cannot move things around, then bring in test doubles. There are 4 kinds of test doubles. Fakes. Fakes usually are third-party systems that give you some responses that are fake response to enable testing. You normally use stubs. Stubs are going to return back a canned response to you anytime you make a request. Mocks are like stubs, except that they can be useful to test interaction and behavior. And the last one is a spy. A spy will monitor calls to the real object. When you use a stub or a mock, you never talk to the real object in the test, through the test, A spy, you actually talk to the real object, but the spy can actually give you back a recording of interactions you had. So in this case, we can use some things like that. So to understand this, let's create a little silly example here again. So what I'm going to do here, I'm going to remove that coverage, if you will. So I'm going to just run the test. So npm test. So in this case, so I did make a configuration error there. So I'll back out of that. So let me back out of these changes. So it's clear that I made a goof up in the configuration that I saved here. So let's try to run the test really quickly. So what am I going to do here? So what I'm going to do here is I'm going to write a little code, and this code is going to say, how should I dress up? So I'm going to call, a t-shirt. So should recommend a t-shirt for a warm weather. So I'm going to ask for, what kind of, clothing I should wear. But in this case, of course, when I ask for this value, what do I need? My code would require expect, and I could say, recommend and clothing, for example. And I could say what city I want to send in. I could say Bangalore, right? And of course, I could say in this case, to be equal to, and I expect a t-shirt. Well, but wait a minute. How could we predict that? Well, the weather could be changing. There could be a cold weather one day, could be a warm weather another day. So you don't want just to be arbitrary. Well, this code is usually going to talk to a little weather piece of code, right? Well, for that, what I'm going to do here is I'm going to create a weather.js, and the weather.js says I'm going to have an object here. We'll call it as weather, and this object is going to have a function called temperature, which is going to be taking a function city, and I'm going to simply say in this case, we'll simply say throw, and the throw is going to say not yet implemented. So if you call it, it's going to blow up. Well, obviously, even if you implement this code, you cannot call into it from your test because it's going to be non-deterministic. So what am I going to do? I really want to call this particular function weather. But to do this, I'm going to call a recommend clothing function. But what does the recommend clothing function do? Well, the recommend clothing function is going to do the following. It says function recommend clothing takes a city as an argument, and within here I'm going to say weather dot, what do I say here? Temperature for the city. And if that is greater than, let's say, what is 80 in centigrade? Let's say 25 degrees centigrade, right? So if it is greater than 25 degrees centigrade, then I want to return a t-shirt. Otherwise, what am I going to do? I'm going to say, return. Nope, we don't know yet. Well, but I want to call this method, run the test. Let's see if that's going to come through. So let's see what we're going to do to run this test. Close that one. All right, so npm test. And what's the fate of this? It is failing expected t-shirt for warm weather, but it's going to fail. Why? Because we haven't implemented that part. It says not yet implemented. Notice that. And it says I'm going to blow up because you called a function that's not implemented. What do I do? So this is where you could try hand toss mock objects. But I came across a tool that just was amazing. I don't think I've ever liked a tool so much. And that's called Zenon. Zenon is one of the most amazing tools I've ever come across. Zenon is wicked cool. If you ever consider having Zenon as your enemy or your friend, you want it as your friend because it's that wicked. And what does Zenon do? It can mock up anything you want it to mock up. So I had to first install, npm install Zenon, but I'm also going to not only install Zenon, I've got to also install the Zenon Karma plugin. So I'm going to bring that in. So I've got a bunch of plugins I'm going to install that are needed. So I'm just going to take a lazy route and just run that again. So in this case, I've installed Zenon, installed Zenon Karma, plugin, all those good stuff. But here's one of the bad news though. Zenon is so powerful, you don't want to use Zenon directly. Because you tell Zenon, go mark this, it'll come back and say, I'm done. And then you're like, oh, thank you, but you changed my entire world. And Zenon is like, isn't that cool? You're like, no, because I got now to run the next test. So the beauty is never run Zenon directly, use always Zenon Sandbox. So Zenon Sandbox is extremely powerful. So how do we use this? I'm going to run the test again. You will see it blow up. Now let's come back here. So back in the test, I'm going to go ahead and say over here, first of all, before each. And I'm going to write after each. Before each is called before any test. After each is called after any test. This dot sandbox is equal to Zenon.sandbox.create. And then of course in the after each, I'm going to say this dot sandbox dot restore. And you're asking it to put the world back together the way it was. So now that you have a sandbox object, what you can do is you can use the sandbox. How do you use the sandbox? I'm going to need more than 1 minute, so quit showing that for me. So what am I going to do? I'm going to go ahead and say, in this case, I want to run this a little bit. So what do I do to set this up? Well, first of all, I'm going to say this dot sandbox, and we're going to ask it to create a stub. Well, in this case, I want to stub the weather objects, temperature method. And then you're going to say, with args, what kind of argument I'm expecting? Bangalore, of course, right? That's what I'm expecting in this case. Well, then once I'm getting Bangalore, what should I do? I'm going to say returns, let's return a 85 degree, well actually 27 degrees in this case. So you're telling Zenon, hey, when a request comes in from this guy, don't send it to the real implementation. Just hijack the call, send it to the stub, and let it return a fake response, a canned response. Well, I'm not saved this yet. My test is failing, and the reason it's failing in this case, even the Canary test is failing. So obviously because I made a mess in the other one, let's fix that. Zenon is not defined, that's the error it's giving us. So I should have brought in the Zenon, so pardon me. Let me comment this out. Let me remove this for a second, we'll come back to it. So let's go back and bring up edit karma.conf.js. And what am I going to do here? I've got to bring in Zenon. That's why it's complaining. So there we go. Now let's run the test. The error should say weather is not implemented, remember? And there you go, not yet implemented. Now, let's come back to the code right here. And now I'm going to go ahead and implement that one thing here, which is that call. So let's go ahead and say, hit the save. Now we are saying, when the recommend clothing is calling weather's temperature, don't go to the real stuff, go to my mock object. Isn't that beautiful? So to prove that it actually worked, I go remove this stub. The test is failing with not yet implemented. I put the stub back, and it says success. So you can mock away your dependencies very easily. And the beauty is, it only affects this one test and not any of the other tests. So all I did here was I showed you the tooling that's available and how we can use some of these to put this together. So the beauty is, if you want to really do automated testing for JavaScript, there is really no excuses. Every tool is available, and guess what? Every one of these tools is free of charge. We don't have to even pay for it. But of course, we need to invest in it, our discipline, our effort. That's all matters. Hope that was useful. Thank you.
Thank you.